done the calculation for the previous questions that I gave in the previous class. Did you try, Anna?
Yes, sir.
And did you get the answer?
Yes, sir.
Okay. So this one and which one? This one, right? So what was the final answer for this one? Anna?
Which one, sir?
What was this one, the 10th question? So what was the velocity that you found?
1/2 F40.
Yes, this was the right answer. Okay. And did you get the same answer, Abhinav?
Yes, sir.
Okay. And the other question was what? So I won't discuss this question. The other question was this one, right? So, okay. Yes. So what was the final answer for this question?
C.
Yes, right. So C was the answer. And what logic did you use to solve this question?
Sir, the those formulas, the S is equal to UT plus half a T square 1.
Yes, why it is not working. Yes, so we used to give information that the difference of V was what? V, right? And the time difference was what? T, right? You used these information, right?
Yes, sir.
Okay, so let's move on to the next topic, which is what? Motion in 2D. And you know that there will be two parameters which will describe the motion in 2D, and that will be what? Your X and Y distance, right? So in earlier classes for the motion in 1D, we had only what? One parameter X, right? And now to describe a motion in 2D, you will have to assign two parameters, the distance in X direction and the distance in the Y direction, right? So the first topic, as the heading says, is projectile motion, right? So let us do the projectile motion. First case is that you are on a building or a rooftop, okay, and you throw something from here, right? So this will follow something like this. So let me rub it. Okay, so this has only one direction of velocity. Let me call it u, right? And this distance is called the height, and this distance that the body travels or the ball travels is called the range. Okay, so this is range, the maximum distance it travels in the X direction. Okay, So Arpit, this is your first class, na?
Yes, sir.
Okay. So we'll try to revise those previous classes at some point. Okay.
Okay, sir.
So this is the y distance. Okay. And there are prior information. And what are those? That this particle has only the x direction initial velocity, right, which is u, and your y initial velocity is 0, right? And what and ax is what? So direction, the acceleration in x direction is what? 0, right? So there is only one force which is pulling it downward, and that is the gravitational force. So you only have, so this is 0, and you only have, and this is in the direction of the gravitational acceleration. So your g is positive, right? And what the information? So only this information. Okay. For this kind of projectile motion, right? So let's try to find out other parameters with the help of these information. Okay. So one is time of flight. Okay. And it is related to the time at which the body was in the air. Okay, the total time for the body which was in the air. Okay, so let's say body or the object covers this distance and comes here, the horizontal direction r. So for time of flight, the x distance is what? For time of flight, let's say t. Okay, so your x distance is what? R, na? Right. Okay. Am I audible? Is that correct? For time of flight, the total distance is r, the horizontal.
Yes, sir.
Right. So, Iram, hi. Hello, Iram.
Yes, sir.
So, did you solve those questions that I gave in the homework?
Yes, sir.
Okay, right, nice. So, everyone has done his homework. Okay, nice. So I was talking about the projectile motion, and in the projectile motion, I was talking about, let's say a body was on a roof, and a body or let's say a particle or what, a stone is thrown with some x direction velocity u, and it goes from here to here. And we are calculating all the physical parameters or the physical quantities which are associated with this projectile motion, right? So we have this prior information that the horizontal speed, the initial speed is u, okay? And this has not any y direction initial velocity. So your uy is 0. And again, it has not any x direction acceleration. So your ax is 0. And ay is g. Okay. So let's solve all those equations, all the kinematic equation with respect to what? With respect to x and y's. Okay. So let's say for x direction, for x direction, let's say this is S. So what will be the kinematic equation? The second kinematic equation? Anyone? So second, let's write to V is U plus AT. S is UT plus half AT square, and the third one. Right. So these three. And we will be using these three. So for x direction distance, your U will be what? UX, right? So UXT plus half AX T square, right? Okay. And for Y direction, this will be what? UYT plus half AYT square, right? Okay. Is that okay with everyone?
Yes, sir.
Yes, sir.
Hello?
Yes, sir.
My internet is it is very fluctuating right now, so it is somehow disconnecting. Hello?
Yes, sir.
Sorry guys for the disturbance. Sorry, I'm extremely sorry. So my internet is not working properly. So up to what point did you
Sir, can you repeat? Your voice cut off?
at what point did it cut off? Can
Sir, when
guys-
you were writing the formulas.
Okay. So you know these information, right? These prior information.
Yes, sir.
Okay. And let's apply the kinematics equation for each part, for the x part and for the y part. Okay. So for x part, this will be what? UXT plus half AXT square, right? Okay.
Yes, sir.
And for the y part, this will be what? UYT plus half AYT square, right?
Yes, sir.
And you know that AX is what?
0.
G.
Right, right. So this will be what? X will be what? UX is U. So this will be what? UT1. Okay.
Yes, sir.
And for the UY part, you have what? UY is 0. Okay.
Yes, sir.
So Y is what? Half GT square, right?
Yes, sir.
Understood. So again, for the time of flight case, for the time of flight, time, let's say T, your X is what? R, right?
Yes, sir.
And your Y is H. Okay.
Yes, sir.
So let's put these values in this 1 and 2 equation, right? So from equation second, you have H is equals to what? Half G T square, right?
Yes,
So
sir.
this will be what? T will be 2h by g root over. Okay. Understood?
Yes, sir.
And from this, your range will be what? So from first equation, your x is what? X is ut, which means that r is u and t, time of flight, right?
Yes,
Okay.
sir.
So this will be what? U, and when we put the value of t here, so this will be what? 2h by g. Okay, so r is what? So r is u 2h by g. Okay, understood up to this point.
Yes, sir.
And so this was the time of flight. Okay, and this was the range. And you already know about h, which is what? H is function of, let's say, half gt square, which means half gt square, right? And so this was dh, right? So let's do one problem based on this, which will make it more clear. Oh, one more thing. Okay, let's solve other thing. So let's say you don't want to calculate the velocity. So let's say you are in the middle. Okay. So you want to calculate the velocity at this point, the position, the velocity, all the other stuff, all the other physical stuff, parameters at this point. So at this point, let's say the time is t, right? And it has what? Two components of velocity, right? One is Vx and the other one is Vy, right? Okay. Understood up to this point?
Yes, sir.
So let's try again the kinematics equation. So your Vx will be what? Vx will be Ux plus Axt, right? Right. And what will be Vy? Abhinav, what will be Vy?
Sir, uy plus ayt.
Right. Absolutely right. So again, we have the prior information that Ux is what? U, Ax is what? 0, and Ay is what? G, right?
Yes,
So we put these values here, and this will be what? A. So Vx is U. So it will be same, the final velocity of this will be the same as the initial velocity in the x direction, right? So Vx is equals to Ux or U. Okay. And what will be the final velocity in the y direction? This will be what? Uy is 0. So Ay is G. So this is Gt. Right. And what is x? X is Ux t plus half Ax t square. Right. So your Ax is 0. So this cancels. So x is what? Ux, which is ut. Right. Okay. Understood up to this point.
yes, sir.
And what will be y? So we are calculating at a point which is time t distance away. Okay, so in the middle somewhere here. We calculated already up to this point, right? We calculated the range or the height. Okay. So what will be y here? Iram? Iram? Anna, what will be y? Abhinav? Am I disconnected or am I audible?
No, sir, we can hear you.
Okay, so why can't anyone tell? So what will be y, Abhinav? This will be uyt, right? Plus half
Yes, sir.
ayt square, right?
Yes, sir.
So uy is what? 0. So plus half ay is what? gt square, right? So y is this. Okay. And
Yes, sir.
and from here we can calculate the value of t, right? T we can calculate from where? Can you tell me? So we can calculate t from here. So t will be what? So t will be from here. T will be x by u, right?
Yes, sir.
So when we put this value in here, your y will be what? Half of g and x square by u square, right? So y will be function of x square. So this is called the trajectory or the path that it travels along the way. Okay. So you can see that y is proportional to x square. So it will behave like a parabola. So you can see that from here. From here, you see that this is behaving like a parabola. So this is the path, the trajectory that we calculated. Okay, understood up to this point?
Yes, sir.
So now we will, and again, so we calculated Vx, and then we calculated Vy. So what will be the magnitude of final velocity? Because your V is what? Vxi plus Vyj. Recall the vector classes. Okay, so your V will be what? Abhinav? V will be what? Abhinav, V will be what? You have Vx, you have Vy.
Vx plus Vy.
Vx square plus Vy square, right? The vector, remember the vector?
Yes, sir. Yes, sir.
So this was what? Axi and Ayj. So magnitude of A was what? Root of Ax square plus Ay square, right?
Yes, sir.
So in the projectile motion, when they ask about the velocity, final velocity at some point t, then you only have to calculate the x component, okay, and the y component of the final velocity using the kinematics equation. Okay, so you calculate the x component and the Vy component, okay, and then you calculate the magnitude of the final velocity using these. using this. Understood?
Yes, sir.
Okay, so let's do one question that will make it more clear. Okay. So this is a question. Let's put it here. Okay. So a relay food package is dropped from an aeroplane which is moving horizontally with a velocity of 30 meters per second. So this is what? Chat, one chat. What is this? Okay. Yes. So what is this? This is what?
Velocity.
Yes, U. This is U, right? At a height of 50 meters. So this is what?
H.
H, right. So they are asking to what? Calculate the time of flight. Okay. The location of point of striking the food package. So this is what? How much distance it has covered from in the X direction. So this is what?
Distance covered in the X direction.
Yes, the maximum distance. And this was what?
Range.
Range, yes. So this was R, right. And velocity of package at the time of striking the ground. Okay. So they are asking about the magnitude of V. So we'll have to calculate Vx and Vy. Okay. And lastly, they want us to calculate the displacement of food package. Okay. So firstly, we'll make a diagram. And from there, we will see what they are asking. Okay. So let's just make a diagram first. And write all the information that we have. So let's say this was the helicopter. Okay. And they threw a food package here. Okay. So, and the height is what? 50 meters. And U is what? 30 meters per second, right? So first question is, and time of flight. Okay. And the other one is what? R. Okay. And they are asking V. And the last thing they are asking about the distance. Displacement of food package. So the food package was here. Okay. And has reached here. So what will be the displacement? What will be the displacement? Arpit.
Yes, sir.
So what will be the displacement from this point to this point? The shortest path, na? So this is the displacement, right?
Yes, sir.
So they are asking about this. Okay. So what was the time of flight? It was something what? 2h root 2h by g. Am I right?
Yes, sir.
So it was root 2h by g. Let's confirm this. Okay. So yes. So it was root 2h by g and R was root 2h by g. Okay. Yes. So what will be time of flight? H is what? 50 and G is what? Let's say 10. Okay. So this is what? 10 seconds, right? Okay. Any doubt? Abhinav, any doubt?
No, sir.
And what will be the range? Okay. So U is what? 30 meter per second. And we calculated this, which is root 10. So 30 root 10 meter. Okay. And now we will have to calculate the velocity. So let's first calculate the x. I don't recall. Vx was what? Ux t. Right. So this was what? ut. Right. Okay.
Yes,
And
sir.
Vy was what? Half gt square. Right. Okay. So Vx is what? U is 30 and T is what? Root 10. Okay. So this is Vx. Okay. This is not, okay, sorry. This will be, so this should be Ux plus 18, and Ax is 0. So this is, so Vx is Ux, right? And Vy is what? Who was telling that it is right? Below. So Vy will be what? Right. So Uy is 0. So this is Gt. Okay. So Vx is what? U, which is 30 meter per second. And Vy is what? 10 into root 10 meter per second. Okay, understood.
Yes,
Hello.
sir.
So what will be the magnitude of velocity? It will be what? Because your V is 30 I hat plus 10 root 10 j hat. Okay. So V will be what? And this is actually minus. Yes. So what will be V modulus? Okay. So this will be what? Understood. Any question, any doubt?
No, sir.
Okay. And what was the last question? So this was the last question, right? So how will you calculate this distance? Abhinav.
Sir, Pythagoras theorem.
Yes, right. Absolutely right. Pythagoras theorem. So this is 50 and this is what? This is 30 root 10. Okay, so D will be what 50 square plus 30 root 10 square. So this is 2500 plus this is what 9,000. Okay. So this is what 51100. So this is 10 root 115. Okay. Understood. Any doubt?
No doubt, sir.
Okay. So now you guys calculate. This is exactly the same question. You guys calculate and tell me the answer. This is exactly the same question. A helicopter is flying horizontally with a speed v at an altitude h, has to drop a food packet for a man on the ground b. Okay. What is the distance of helicopter from the man when the food packet is dropped? Okay. So they are asking about this distance. Okay. And they have given this distance. Okay. So they are asking about this question. Okay, just calculate and tell me the answer. U is what? V. Okay, so no, this is what? This is H. Okay. So who is calculating? Hello. Abhinav, Iram, Arpit, Anna, and who has joined recently? So who is calculating right now? Anyone?
Yes, sir, I'm doing.
So you are doing the calculation, right?
Yes, sir.
Okay, so just calculate and tell me the answer. Abhinav, are you doing the calculation? Abhinav, are you with us? Abhinav? Iram? Okay, so they are deeply into calculation or they are. We have to follow the same procedure that we did in the previous question. Only that we have only the H and V here. Instead of the value of 30 meter per second or the value of 50 meter, we have this H and this V, right? Am I correct?
Yes, sir.
So did you find the solution, Arpit?
So I'm just at the last step, so wait a second.
Okay. So let's just solve it together, and you tell me that if my approach is wrong or right. Okay. So let's just try to calculate. Firstly, we'll have to calculate what? To calculate D, we have to calculate R, right? If we know R, then surely we can calculate this T, right? Okay. So what was R? It was U 2H by G, right? Okay. Hello.
Yes,
Yes,
sir.
C. Okay, let's see if C is the answer or not. Thank you for solving it. Okay. So this is what? V 2H by G. Okay. And what will be D? This will be what? H square plus R square, right? So this will be what? This will be V square 2H by G plus H square, right? So V square 2H by G plus H square. So this is the correct answer, right? So you got the right answer. Okay. Hello.
yes, sir.
Okay. So we'll move on to the next question. Let me see what is the next question. Or okay, so this is at some angle. So firstly, we will calculate. Let's say you have a projectile which is projected at some angle. Okay. So in these questions, it was only the horizontal velocity that it was projected with, right? Okay. And now we will project it with some angle. So let's say you have a projectile and which is projected like this. So this has some inclination angle, and this is the vector u, the initial velocity vector. Okay, so now we will use the same logic that we did with the previous question. Okay, so what are the prior information that we have? So this is the vector u, and this has the x component, and this has the y component. Okay, so in here this has the x component, and this has the y component. Similarly, you have the x component and the y component. Okay, so this is u. So what will be the x component here, Abhinav? This is theta. So what will be the x component from the vector classes? Abhinav? Iram, what will be the x component? Anna? Arpit, what will be the x component here? Why is everybody silent? I don't understand. So this will be u cos theta, right? Okay. and this will be u sine theta. Okay. Any doubt?
No, sir.
Okay. So your x component is what? So acha, Abhinav was not in the class. Hello Abhinav. At what point did you leave the class? Hello. Hello. Up to what point you were with us? Abhinav.
Sir, we finished the question.
Acha, we finished the question. Okay. So now we are calculating the projectile motion at some angle. Okay. So
Yes, sir.
with some angle, the projectile is thrown. Okay. So the initial velocity will have two components, right? The horizontal component and the vertical component. Okay.
Yes, sir.
Right. So what will be the horizontal component? U cos theta, right? From the vector classes.
Yes, sir.
And the vertical component is u sine theta.
You sine
So
theta.
yes, so just let's write all the information that we have. So ux is what? U cos theta, right? And uy is what? U sine theta. And your ax is what? 0. Your ay is now. You see that it is going with the gravity or against the gravity. Arpit, it is going with the gravity or against the gravity?
Sir, with the gravity.
You are throwing it upward. And gravity
Upward,
is
against,
yes.
I guess.
Okay, so it is going against the gravity, right? That's why it is coming down. Na? At some point, its velocity is 0, and then it is coming down. So it is going against the gravity, which means you have a minus here. And what are the other information that we have? Okay, again, so the maximum distance that it covers is what? Range, and the maximum height that it goes against the gravity is h. Okay, so these are the information. Maximum, let's say r, and let's say h. So these are the prior information that we have. Okay, and we will use these informations and try to solve the range again and the height. Okay, and the other one was what? The time of flight. Okay, so let's break this projectile into two parts. The first half, where it reaches the maximum height. Okay, and the other part, which is exactly at the same time. It is happening with the same time that whatever time it takes to reach here, the equal amount of time it will take to reach here. Okay, so let's say your time of flight is t, right? Let's say your time of flight is t. So what will be the time to reach here? What will be the time to reach here? The half time, na? Right?
Yes, sir.
So t by 2. Okay, any problem?
No, sir.
Okay, so let's, you know that when it reaches this height, what quantity you can assuredly tell that it will be 0?
The velocity.
Yes, the vertical velocity. It has some horizontal velocity, but the vertical velocity is 0, right? Right, na?
Yes, sir.
So you're at, let's say, at maximum height. Let's say h. What do you have? Your Vy is 0. Okay. And time is what? T by 2. So let's apply these two things and calculate what will be Vy will be what? this will be uy and plus ayt, right? Okay. Any doubt?
No, sir.
So Vy is what? Vy is what? At maximum height, it is 0, right? And your Uy is u sine theta. Okay. And Ay is minus g, and T is what? T is?
E by 2.
Yes, right. So T is T by 2. So you get what? Gt by 2 equals to u sine theta. Okay. So your T will be what? 2u sine theta by g. So this is the time of flight. Okay, understood? Any doubt here?
Yes, sir. No, sir.
Okay. And now we will calculate the range. So for the calculation of range, you have what? Your x is what? uxt plus half axt square, right? Your ax is 0, so this is 0. Okay. So at, let's say, at maximum distance. Okay, so your x is what? R, and your t is what? T, right? Right or wrong? Right or wrong?
Yes, sir.
Okay. So your x will be what? This will be R, ux is what? U cos theta. Okay, and t is what? T. And we will use this formula of time of flight. Let's say this is time of flight. Okay, so this is u cos theta t, which will be what? U cos theta into 2u sine theta by g, which is what? 2u square cos theta into sine theta by g. And can anyone tell me what is 2 sine theta into cos theta?
Sine 2 theta.
Right, this is sine 2 theta. So this will be what? Oh, so this is
X square sine 2 theta by g.
yes, u square sine 2 theta by g. So this is range. Okay, and what other parameter is left? The height. Okay, so let's try to calculate height. So what was your height? It was h was uyt plus half gt square, right? This was the height, no? It was minus. Okay. Understood? Hello? Hello?
Understood, sir.
Okay. So this is what? H is, uy is what? U what? U sine theta, and this is what? T by 2 minus half g t by 2 square, right? So this is what? U sine theta. Should I calculate v square minus u square 2gh? So let's try to calculate with this. So u sine theta, and what is t? What is t here? Oops, sorry. So t is 2u sine theta by t. Okay. So yes. So t is what? 2u sine theta by g. Okay. Minus of half g 2u sine theta by g2 square. Right. So this is what? This is 2 cancel. So this is u square sine square theta by g minus of half g, and this is what? 2 cancels. So this is what? U square sine square theta by g square. Right? Okay. So this is what? U square sine square theta by g, and this is half of u square sine square theta by g. Okay. So this will be what? This will be u square sine square theta by 2g. So this is h. Any question? Any question up to this point?
No, sir.
No, sir.
Okay. Okay. Good. So what was your, this was 2u sine theta by g, okay? And your r was what? U square sine 2 theta by 2g or g? What? It was g. So g, right? So for an inclination angle of theta, you have the time of flight, okay, and the height, maximum height, and this is the range. For a projectile projected at some angle. Any doubt up to this point?
No, sir.
Okay. So at what? Let's calculate. So you have h, which is what? U square sine 2 theta by 2g, right? And your r is what? U square sine, this is sine square, right? So this is u square sine square theta, okay? And this is u square sine 2 theta by g. So at what angle? At what angle your r and h is maximum? So from what angle you have to throw the projectile so that your height, you achieve the maximum height as well as you achieve the maximum range for a projectile, okay? And what this will be? For r max, your sine 2 theta should be 1, okay? So 2 theta should be what? What is the maximum value of sine and cos? maximum value of sine theta. Maximum value of sine theta is what? Abhinav. Maximum value of sine theta will be what?
Pi by 1.
1. Yes, right, 1. So maximum, because the range of sine theta is what? -1 to 1. Okay. So the maximum value that sine theta can have is 1. Okay. So you want to calculate R max. So for R max, U is fixed, right? G is fixed, and it depends upon theta, right? So your sine 2 theta is maximum at 1. So your sine 2 theta is 1. So theta 2 theta is what? 90, right? So theta should be 45 degrees. Okay. So if you throw the projectile at an angle of 45 degree, you will achieve the maximum horizontal direction. Okay, understood? So R max will be what? U square by G. Okay. Understood? Okay.
Yes, sir.
Yes, sir.
And to calculate H max, you have to throw it perpendicularly, right? So you can achieve the maximum height. Okay. So for H max, you throw it perpendicularly at theta equals to 90. So this is 1, so U square by 2G. Okay. And you know that U square by G is what? R max. So your H max, is what? R max by 2. Okay, any doubt up to this point? Any questions?
No, sir.
Okay. So now, finally, what we did in the previous section for the projectile motion without an inclination angle, we calculated what? We calculated the trajectory, na? It came out to be a parabolic equation, right? Okay. So again, we will calculate the trajectory for at some time t. So again, trajectory. At some time t. Okay, let's just calculate this. So this is so let's say at some point t. Okay. So what are the information that you have? You have ux is what? U cos theta. Uy is what? U sine theta. Your ax is 0. Your ay is minus g. And time is t. Okay. So using these information and we will calculate the trajectory. Trajectory means y as a function of x. Okay. So we have to calculate y as the function of x. Understood? So let's calculate x. X will be what? Abhinav, x will be what? Abhinav. X will be? This will be uxt, right? Plus half axt square, right? So this will be what? U cos theta into t, and this is 0. So are there any doubt why no one is speaking? Any doubt up to this point? Any question? Hello?
No, sir.
Okay. So what will be y? Tell me, what will be y, Iram? The vertical distance.
U
This will be what?
sin
Yes?
U sin t.
Yes. This will be uyt. First, let's try it in this way. This will be uyt plus
Of ay t square.
right. Okay. And now put the values of uy, ay. Okay. So let's put the values of uy and ay. So uy is what? U sin theta, as you were mentioning, and t. Okay. Plus half ay is minus g. So this is minus g t square, right? So this is y. Okay. Understood?
Yes. Yes, sir.
And I am my goal is to calculate y in such a way that it is what? A function of x, right? Right? Huh?
Yes, sir.
And you see that from here it is a function of what? T, right? Right.
Yes, sir.
So we have to remove this t from here and put x somehow. So we will use this equation to find the value of t, right? So this will be what? X by u cos theta, right? And we'll put this value of t in here and we'll be over with the t for part, and this will be the function of x. Okay, understood?
Yes, sir.
So let's put the value of t here. So this is what? This is u sine t is what? X by u cos theta, right? And minus of half g x by u cos theta square. Okay, right? So this will be what? U cancels. So sine theta by cos theta is x tan theta, right? And this is what? Half of g x square by u square cos square theta. Okay.
Yes, sir.
So this is the trajectory that I was talking about. It again is a function of x square. So it follows the parabolic equation again. Okay, so this again follows a parabolic type of path. Understood? So this is the trajectory, and this is very important. Trajectory of projectile. Okay, any question up to this point? Any question?
Yes, sir.
Okay, so the projectile is completed and we will do some questions based on these. Okay. Yes. So who's going to tell me the answer of this question? So the velocity of a projectile at the initial point A is this. So your u vector is given. Okay. 2I plus 3j. Right. So this is uxi plus uyj. Right. Okay. Any doubt?
No, sir.
And it is asking about its velocity at point B. Let's say point here. Okay. So can you recall that what velocity doesn't change in the course of this projectile motion? What velocity? Can you guys recall? Do you guys remember that I was telling about this velocity remains the same? So I was talking about which velocity? The horizontal velocity, na? Your ux doesn't change because Vx is what? Ux plus axt, and your ax is what? 0, right? So Vx is always equals to ux. So horizontal velocity doesn't change, right? Okay. Understood?
Yes, sir.
Okay. So in this question, let's look at these options. In this one, the horizontal velocity changes. So this will not be the correct option. Again, this is not the correct option. Okay. And in here you have this velocity and this velocity as the final one. So you see that this is exactly the same, the D1. So this can be true because your final velocity can't be the same as the initial velocity, right? These are the vectors. So this will be true. Any doubt? Any doubt about this question?
No, sir.
Okay. So let's try to calculate the other one. Just take a screenshot of this question, okay? No, let me solve this question. Okay. So a projectile is fired from the surface of the earth with a velocity of 5 meters per second at an angle theta with the horizontal. Another projectile fired from another planet with a velocity of 3 meters per second at the same angle follows a trajectory. So when you hear the name trajectory, what equation should come into your mind? When you hear the name trajectory, what equation should come into your mind? This equation, na? And what was it? U square by sine square theta. What was it? Yes, so x square by u square cos square theta. So half g x square x square by u square cos square theta, right? So you have to use this equation, and they are saying that trajectory is same. So x is same, your angle is same. So this is the same, only your x is same, again trajectory is same, your theta is same. Okay, only it is dependent upon the initial velocity g, the gravitation, and u, because on the other planet your g is different, right? And u is different, because it is 5 meter per second here and it is 3 meter per second here. Okay, so you use this equation and try to calculate what g prime. So this is your homework. Okay, hello, just take a screenshot of this question and tell me the answer in the next class. Okay, okay everyone, is that okay with everyone?
Yes, sir.
Okay. Okay, so let's do one question and then we will end the class. Yes, this one. So this is exactly the same question as before. The trajectory of a particle in vertical plane is this. Okay, so what was the trajectory equation? It was what?
Y is equal to x tan theta minus 1/2 gx square by u square cos square theta.
Right, right. Right, so this was the trajectory equation. Okay, and in here they have written the trajectory equation like this. Okay, so we can compare this one and this one, right? So when we compare, the coefficient of x is what? Alpha, and the coefficient of x is what? Tan theta. So from here we can interpret that your alpha will be what? Tan theta, right? So your theta is tan inverse alpha. Okay, so what were they asking? They were asking about the angle of projection theta and the maximum height attained h, r respectively. Okay, so what was the maximum height? Can you recall? It was something like u square sine square by 2g, right? It was like this, na? Right? What was the maximum height?
Yes, sir.
So is that correct? Should I go back to
Yes,
the...
sir.
Okay, so if this is correct, then let's solve on the basis of this. Okay, so they are asking about the theta. We calculated theta, right? Okay, and now they are asking about this h. And you see that they are all in the option, they are all in the function of alpha and beta. Okay, so we have to change all these in the function of alpha and beta. So what is the value of beta? Can you guys tell me? What is the value of beta? Abhinav, what is the value of beta? Compare these two.
1/2
Right?
g by u square
Right,
cos theta.
right. So this is beta, right? Okay. And you see that you have h square sine square 2 theta by 2g. So we calculate the value of what? Let's say we have to write in this form somehow. Okay, so we want to calculate as a function of we want to calculate as function of alpha and beta. So we have to omit this part, okay, and we'll have to u square amplitude, right? Okay, so let's say you have tan theta here. Okay, you have tan theta here. So we multiply, let's say this is beta, and this is g by 2u square cos square theta. So we want to make it tan theta, right? So what should we multiply here? What should we multiply here? We want to make this function. So this is cos square theta in the denominator. And what should we multiply here to make it a tan theta? Sine square theta.
Sin
Na?
theta.
Yes, sine square theta. So multiply sine square theta and divide by sine square theta. Okay. Right.
Yes, sir.
Okay. So this will be sine square theta by cos square theta is what? This is alpha, na? Right. Tan square alpha square. Right.
Yes, sir.
So this is alpha square. And you calculate u square sine square 2 theta by g. Okay. So u square sine square theta by g is what? Your u square sine square theta by g is what? 2h. Right. Okay. Any doubt?
No, sir.
So this will be what? Alpha square by 2h. Okay. And 2 was here already. Any doubt? Any doubt? Any question?
No, sir.
No, sir.
So, okay. So your beta is what? Alpha square by 4h. So all are in function of alpha and beta. Okay, so your h will be what? Alpha square by 4 beta. Right. So where is alpha square by 4 beta? So this one. Understood? Any doubt?
No, sir.
Okay. So we'll end the class here, and next we'll do the circular motion in 2D. Okay. And I have given one question. Let's